Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Developer Express. Become a UI superhero with Dev Express controls and libraries. Deliver elegant .NET solutions that address customer needs today. By leveraging your existing knowledge, you can build next-generation touch-enabled solutions for tomorrow. You can download your free 30-day trial at dx.hanselminutes.com. That's dx.hanselminutes.com. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Paige Bailey. She is a data scientist, machine learning, and AI expert. And you've done a bunch of cool stuff. You've worked in the what is it called? Geosciences, like oil, and you worked at Chevron, and you did work with NASA and physics and the space.
Absolutely. So my background is geophysics and carbonate geology, and that meant that I got to do a lot of interesting stuff with subsurface geoscience, and then also for planetary science, which is learning how our Earth can tell us a little bit about other planets. So yeah, it was a lot of fun.
So you were using machine learning and data science and things like that to ask questions that you did not know the answer to?
Absolutely. So the most of the work that I did at Chevron was around drilling optimization and completions optimization. So drilling optimization is like how fast can you drill a well? And completions optimization is how well can you get the oil out of the ground once you've drilled it? So how effectively can you hold open the wellbore itself and facilitate the movement of hydrocarbons, which is just gas and oil, back up to the surface?
Wow. The reason that I bring that up and why that's interesting is because we're going to talk about machine learning kind of 101 here. But what I like about your background is it's extremely practical. There's a lot of people who talk about machine learning in a very theoretical context and data science and all those things. But to understand it and use it in a real practical and physical way, I think is really interesting.
Right. Like there's so many kind of toy problems available online with very structured data. And, you know, it's always very simple to see kind of machine learning problems subset into 300 records and like maybe 4 or 5 variables, and all of the data is nice and friendly, and you get a very clear result. But in the real world, it's hardly ever like that. So,
right. The real world is quite dirty. One of the things that I have a little bit trouble with is that I tend to clump together all these different technologies. I did it even in your intro. Data science, that's a thing. Machine learning, that's a thing. AI, that's a thing. But for someone like me that doesn't know what any of those things mean, I just kind of clump them together into the general family of like data science and machine learning. Maybe you could tease those apart for us.
Oh, well, so I'm glad that you said that, because everybody seems to have an opinion about what data science is, and none of them are the same. So you were in very good company. But data science is actually kind of a conflation of something called data engineering, which is, sort of typical tasks that a database engineer would do. So building data pipelines, getting everything into a consistent format, doing a lot of data cleaning. So making sure that everything is in this, all of your data types are similar, they're all spelled correctly, they're all in consistent formats. Then there's also the additional component of the statistical analysis. So looking at data and making sure that if you have a certain population, those populations are evenly represented throughout the data. And then machine learning is more the predictive modeling aspect. So if you're doing machine learning, you're usually building a model. Hopefully you have enough understanding of statistics to know that the data that you're inputting into the model is a representative sample of a whole. And then deep learning is just doing predictive modeling on a whole bunch of data, so higher dimensional space, and usually leveraging a GPU or something like a Spark cluster. Yep. So that's kind of, does that make a little bit more sense? So data science is a conflation of data engineering, statistical analysis, and machine learning. Machine learning is something that you do if you want to do predictive modeling.
Mm-hmm.
And deep learning is just doing predictive modeling on a whole heck of a lot of data, and usually higher dimensional spaces, and usually leveraging something like a GPU.
Okay. So how much data do I need before I get to call myself a data scientist? Like I spent a lot of time in tens of thousands of records in Excel 20, 30 years ago. So I must have been doing data cleaning and formatting and structuring. And that sucked.
Well, yes, it does suck all the time. But I mean, there's no fun aspect of data cleaning. Like 90% of your job as a data scientist is getting data into a nicely wrangled format.
Okay.
But I would say if you look at the examples of machine learning online, a lot of models are built using like 500 records. So very, very little, like 500 lines in an Excel spreadsheet with like 6 or 7 columns. And that could build a predictive model, you know?
Okay. So it's not about size. Like when I say data science or we say machine learning, I don't need to have terabytes of stuff. Like that's a good myth for us to bust.
Absolutely. You don't need terabytes of data at all. Like, and if you want to do deep learning, so I think there was an example. There was an example with something called cognitive services recently, where you can train a model to recognize a face using just 5 or 6 photos of that person's face. So it's as long as you have kind of like a base that the computer can understand. So like they know where the eyes are, they know where the eyebrows are, they know where the nose is, the mouth, and those sorts of things. They can kind of suss out the characteristics of a person's face very quickly.
Okay.
And it's also kind of like when your Surface Book or your iPhone or something recognizes your face and uses that to unlock it. That's using a deep learning model. But it's certainly not, terabytes and terabytes of data about your face. It's just taking a couple of pictures of it at a time.
Okay. Now we've talked about and conflated 2 different kinds of data. Like I can think about like Excel or, would it be 2-dimensional data, like rows and columns, and then, or rows and many columns. And then you mentioned pictures, which is that like my system brings in JPEGs and bitmaps, or is that my system thinks about matrices with RGB values?
So it's usually, so it could be either one, but usually it's the latter, the RGB values. So if you pull in a picture into a deep learning model, the first step is usually that it turns it into 3 different components, right? So you have your red values, your green values, and your blue values, except they're in a different color spectrum. And then the model kind of runs on those pixels and starts to pick out which components would indicate a cat or which components would indicate a dog. And the thing about deep learning, so machine learning, you have things like random forests and decision trees and, linear regression and all of those wonderful things that you've probably heard about. And for deep learning, there are a lot of different algorithms there as well, but they're less easy to kind of audit, right? So if you build out a decision tree, it gives you a series of yes or no questions. So the example I always like to use is if you have a decision tree model that determines whether or not a person gets a loan. It'll probably look at things like how much money's in their bank account and whether or not they're employed and whether or not they've defaulted on a loan before. And using that information, it'll say like, oh, well, their bank account is currently overdrawn and they've defaulted on a loan before and they're not employed. So let's not give them a loan again,
Okay.
And that would be each one of those questions would be a branch in your machine learning decision tree.
Okay.
And
so deep learning is more structured and it's part of that family of machine learning things.
Yes.
Okay.
and it's harder to audit. So like I said, the decision tree, you would be able to point back at those questions and say like, oh, well, we answered no and no and no, and so we didn't give them a loan. And that way, if somebody tried to sue you, you would have an answer. Whereas deep learning, you give the computer the data and you say, computer, give me an answer. And the computer gives you an answer and it's right, like 99% of the time, but you have no clue what it's up to.
Okay. That seems to, that there's lots of different angles to come at what's the difference between deep learning and machine learning question. But that one is like, I put in an input, a function ran, but the function is a black box and a miracle. And the answer came out and it was an amazing answer, but I can't tell you why. I just know that it was right.
Absolutely.
That's why a lot
learning. Yep. And that's why a lot of companies really, really feel, a bunch of misgivings about using deep learning algorithms. Because if you have something that's like very high stakes, so you're investing billions of dollars, you kind of want to know, like, okay, well, give me some rationale as to why I should invest billions of dollars. It's not very. You get a lot of misgivings if the computer's giving you an answer because, for all you know, it could be wrong. Even though when you test it, it's mostly right.
I've heard people refer to like the family of artificial intelligence in a number of different ways: machine learning, deep learning, and then this idea of good old fashioned AI. Like they'll sometimes write it as an acronym, GOFAI, to like the kind of the more classic, straightforward, understandable things, and then like all the different things you listed off, linear regression and decision trees, which are all different sub flavors, right? So there's like the family of creamy desserts, and then there's ice cream, and there's gelato, and there's and there's all the different things. And sometimes you just want to get back to the basics. And you're saying that people are concerned about deep learning because it's this leap that jumps over good old fashioned AI and things that we understand into this much more complicated world.
Absolutely. It's going to revolutionize the way people write programs. So it's no longer the typical programming where, you have if and else statements and it's very structured, like little Lego bricks building out a thing. It's suddenly, the computer's creating software of its own, and the human has less of a hands-on, less controlling sort of role.
Hey everyone, this is Scott. I want to take a minute and talk to you about Smarty Streets. You've probably already heard about them. They provide APIs for address validation and geocoding that cover most every address on the planet. Their fans describe their services as having dead simple APIs that are blazing fast with fantastic documentation, and they provide unlimited tech support and 100% uptime. I actually met these folks personally a few years ago at an event in Las Vegas. Not only are they extremely knowledgeable, they're a lot of fun as well. They're definitely worth your time to check out. So go check out smartystreets.com/HanselMinutes today and try out their full API demos for free. So let's pop a little bit off the stack here because we got really deep really fast and I wanted to talk machine learning 101, and I am not a data scientist. I don't even play one on TV, but you are. So let's say you and I are on a team, or the listeners who are also not data scientists are on the team with you, and they're hearing things about doing machine learning and consuming it, and they hear about Python and they hear about R, and then they wonder if they need to learn one of those things if they want to interact with you as a data scientist.
So the answer is no, and which is a great sort of thing. Most machine learning algorithms and most deep learning algorithms are implemented in Python and R. But if you're a developer who's, tasked with building an application that just takes the input or the output of a model or sends an input to a model, really all you need to know is how to interact with a REST API. So what you should all be telling your data scientists is if the output of their model is like a CSV file with a whole bunch of values, and they can't give it back to you in a structured JSON format or something, that is not acceptable. That they need to be giving you something that you could incorporate into your application.
Okay, so I can think about this entire universe, this entire world of artificial intelligence and machine learning as functions, inputs and outputs, and I can hopefully consume them in a way that will make me feel smart, but will be really easy to do.
Absolutely. And it's a personal opinion that the data scientist should be the person who is responsible for checking to make sure that the model continues to operate as it should. So over time, you might end up with something called data drift or model drift, which is that when the data scientist creates their model, creates a model that predicts the number of widgets that are going to be sold in July, or predicts the price of oranges in July. They might get some additional information, after their model's been created that would change the model's behavior. So say if I'm predicting the price of oranges in July of next year, and then suddenly, in January, there is a huge disease for every orange orchard in the world. That would probably cause the price of oranges to skyrocket. So if you were using the model that had been built today, though, you wouldn't have that information included. So as your model is deployed, you need to keep refreshing it with new data. So kind of the DevOps component of data science. And you need to make sure that your accuracy stays to the level that it's supposed to be.
Okay, so that's interesting. So let me see if I can paraphrase and understand what you just said. So we could do something around recognizing faces, but faces change, although they change over centuries rather than over months. If I'm doing something over a period of years or seasons, like you described, something that's more temporal, I could use the last 100 years, but then in a year or 2 or 5, that's going to become old. So then I'm going to need to, and I think you had told me before, the word is operationalize the model. Yep. You design a model, and then you deploy it, put it out into the world, wrap it up in a convenient web service. So it sounds like you're telling me that I need a DevOps plan for my machine learning department and my models so that I can take those functions and deploy them the same way that I deploy any code.
Absolutely. And you also need to be tracking the accuracy of your models over time in order to understand what that cadence should be like for how often you refresh your data. Because it's all based on business rules, right? Like it might be, like you said, refresh it once a year, or it might be refresh it every night or every week or every month.
Okay, so then how do I decide? I decide based on the kind of stuff that we're predicting. It could be predicting the price of Bitcoin, or it could be predicting how continents shift, which are going to be different levels of operationalization.
Absolutely.
Okay. All right. And it's in R or it's in Python or whatever. I'm going to deploy it to a server. I did some very minor machine learning stuff, and the model that was generated seemed small, like from the perspective of as a file on disk. It was a small thing.
Absolutely.
That kind of freaked me out because we had pulled from a couple of terabytes of data and then a couple of megabytes popped out. How is that possible?
So think of your model just like you would think about an equation, right? So the gentleman who made physics, like the very, very bright folks who did all the experiments and discovered that, acceleration due to gravity is 9.8, they probably ran a ton of experiments where they were dropping all sorts of things from all sorts of heights and writing down numbers over extended periods of time before they came up with that, it's 9.8 meters per second squared for acceleration due to gravity. But we don't really care about all the data that it took to generate that number. All we care about is that if you drop something from a height, now we have the equation that can tell us how fast it's going to fall and when it's going to hit the ground. So your model is just basically that equation, right? Like the ton of data was used to generate what that equation should be, but now you've got the equation and you can just apply it to whatever inputs and outputs you have. Does that
Okay, but
make sense?
it's not an equation that I can see. It's just binary bits in this model. It's not an equation I could express and draw.
Yep, it won't be unless it's something like a linear regression algorithm, which would give you kind of like a y equals mx plus p kind of thing.
Okay.
But whatever your model is doing, it's basically just an equation or a recipe on what output you should be getting if you input a certain thing.
How do I debug it then if I can't look at it?
So debugging is really interesting when it comes to machine learning and to deep learning. So machine learning, it's a little bit more straightforward. So you can tweak these things called hyperparameters, which are just kind of inputs to a function. So an example would be there's this thing called a martingale, which is a wonderful name. If I ever get a pet bird, I'm going to name it martingale. But a martingale, just think of it as kind of like a window for a running average. So you could take the last 5 values to get your average, or you could take the last 10 values to get your average, or the last 2 values to get your average. And the number of values you select is called a martingale, right? And that's an example of a hyperparameter that you could tune for a model, is how many values you use to generate an average. So so each machine learning model has a variety of those kinds of hyperparameters that you can just keep shifting around until you find one that gives you the highest accuracy or whatever value you care about. And then once you've tweaked those hyperparameters appropriately, that's kind of how you debug your model. Or it could be that so you have this data set, right? Mm-hmm. So say you have a data set that predicts how long a person's going to live, and you have things like how many, what their weight is, what their blood pressure is, how many calories they eat per day. And then you might have a whole bunch of fields that are like plays soccer, goes jogging, goes hiking, and those would all be yes or no values. It could be that you could consolidate all of those sort of physical activity columns into one column that's just like is active. And so that consolidation process is called feature engineering. So being able to look at a data set and say like, oh, well, I think all of these are kind of telling me the same thing. So let's just put them into one column as opposed to 6 columns. And that could improve the accuracy of your model.
Yeah. That word martingale. Yeah. My sister-in-law has horses, and the martingale is part of the reins of the horse that keeps it from going too high. I wonder if that relates somehow to using it in the context of data and making sure that the data doesn't go "quote unquote" too high.
Awesome.
Interesting.
It could be. Yep.
Yeah. That's another whole like podcast we could do on etymology of words, because martingale goes back hundreds and hundreds of years. So then, if the model, what's the difference between overfitting and underfitting? Because you described a model that worked really well, but if the model that works too well, that can be a problem as well.
Yes. So deep learning, that's another reason why I don't like it as much as I should probably. But so deep learning, it's incredibly effective. It is ridiculously effective, and I think it's going to be the way that most machine learning goes in the future. But there's an issue with deep learning where, so say you have a picture of a panda. It's very obviously a panda. Mm-hmm. And your deep learning model looks at it and is like, good job, Paige. I'm 72% sure that's a panda. If you add one red pixel in a very specific location on that picture, dependent on the picture. So you just add one red pixel, or you introduce like 0.07% noise into that picture. So it still looks the same to the human, other than that one red dot, or it still looks the same to the human, other than like maybe a little bit more greenish. Then your deep learning model could look at it and say, you know what, Paige, 99% sure that's a camel.
Seriously.
Yeah, and it still looks almost exactly the same to the human, right? Like it's still very obviously a panda, just a panda with one red pixel dot. But your deep learning model is completely confused. Or you probably saw in Hacker News recently, there was like a turtle that TensorFlow thought was a gun. And no matter which direction it looked at it, TensorFlow was just dang sure that that was a gun. Yeah.
Okay,
So,
that's really concerning if the thing's job is to recognize, guns. Like if I brought my turtle to the airport and the machine learning algorithm decided I was a bad guy.
right. And the thing I worry about too, right, is that if you have a company that's tasked with determining missile locations from satellite imagery, and they have, a bunch of satellite images that have been classified as like, oh, that's a location with missiles. Oh no, that's not a location with missiles at all. If you have, some bad actor who introduces, again, just 0.07% random noise to a corpus of images, they would still look exactly the same to the company that's analyzing the satellite imagery, but suddenly none of them would be correctly classified. So you would have like an area maybe with civilians that was classified as probably a missile location, or a place that was a missile location that was classified as innocuous.
Okay, so pushing back a little bit on that, or pushing on that, because that is totally freaking me out. How does that kind of stuff not completely invalidate machine learning and AI, and how could I ever trust it again?
So, lucky for us, there are a bunch of really smart people working on these problems. If you have interest in the subject, it's called adversarial machine learning. So being able to,
machine learning.
yep.
Okay.
So being able to spot, some of those issues with your algorithms before they become issues. There's a project run out of Google Brain called Clever Hands, that is specifically focused on how to detect those like one pixel problems, and how to prevent against them. And what they're actually doing for some of the research is using deep learning to test other deep learning algorithms. So like you're using deep learning algorithms against each other to make each other better, over and over and over again, which is fascinating.
Interesting. It reminds me of like making a copy of a mixtape, except it usually gets worse.
Yep, but for whatever reason it just keeps getting better. It's like I believe AlphaGo, that was one of the methods of training it, was that you just keep using smarter and smarter algorithms against each other. And
AlphaGo is the Go algorithm that beat a human?
The Go algorithm that beat a human, and that kind of trained itself very, very quickly to beat Go. There was also recently, I'm not sure if it was AlphaGo or if it was something else. It learned how to play chess by itself just by looking at a number of games, and it learned very, very quickly. So like,
oh wow,
yeah.
So you do this all day. This is your job full time. You're thinking about this stuff. I am just a lowly programmer. When I see things on the news where it says, Elon Musk says that AI is going to kill us all, that is concerning to me. How do data scientists in the community feel about statements like that? Like, is Skynet going to be a machine learning model?
I heard that Skynet was going to be JavaScript, but or it was going to be written in JavaScript. But so it's so funny too, because Elon Musk, is very emphatically against AI, but he's also including it in every single one of his products. So like the self-driving components of Teslas, that is definitely AI. But I honestly, I think that the way that AI is going to be potentially detrimental to society is if we don't take care to make sure that our algorithms are implemented in an ethical way. And I understand that you had a recent Hansel Minutes about ethical algorithms as well. So,
yes.
but I honestly think that it's not going to be, AI creates Skynet. I think it's going to be that there are going to be more and more decisions being made by algorithms that impact already marginalized groups in a very negative way. And that's something that hurts my heart.
Why would you think that Elon, being presumably a smart person, would say something like that so emphatically, or do you think that's just the media overselling it?
I think it's probably the media overselling it, and then it's also, a great way to ensure that other people aren't really practicing as much AI as they could be, right? Like maybe it's a business tactic. So, but and it's also those kinds of broad statements. Nobody can really predict the future other than maybe Neil Stephenson. Like he seems to be pretty dang good at it. But the deal with AI creating something like HAL or something like, the crazy things that you see in science fiction novels. I don't, like I said, I don't think that that's going to be the thing that potentially harms humanity. I think it's going to be a little bit more nuanced.
Well, certainly it's a tool, right? And it's feasible that someone could use that tool or JavaScript to hurt humanity. But I guess the idea is you don't think that it's going to happen on its own.
No.
Like if a bad actor or a bad guy or gal decides to do something evil like that, that's one thing. But for them to for the thing, the AlphaGo, to do it on its own, you find unlikely.
Absolutely. That's a perfect way to describe it.
All right. I will sleep better. I will probably never play Go well again, but I will I will feel much better. Thanks so much for chatting with me today.
Oh no, this was a ton of fun. I love talking about machine learning. This doesn't feel like a job.
Where can people find you online and learn more about what you're doing and learn more about machine learning?
Oh, a ton of places, but my Twitter handle is probably the best way to find me. It is Dynamic Web Page, with Paige spelled like my name. And then I'm also Dynamic Web Page pretty much everywhere on the internet. If you want to learn more about AI, I sincerely recommend either the AI School from Microsoft or Deep Learning or Machine Learning from Andrew Ng. Both of those courses are available on Coursera, and they're both phenomenal. And there's also a website called DataCamp, so datacamp.com, that teaches you everything that you would ever want to learn about machine learning with Python or R. So data cleaning, data processing, building out machine learning models, doing deep learning, all of that is available for like $29 a month on DataCamp, and it's for free if you're a student. So,
rock on! Awesome tips. Yep. Thanks so much. This has been another episode of Hansel Minutes, and we'll see you again next week.